Thilly is getting ready for a date with Ash and wants to impress him with her CRABS talent. CRABS is a game played on a pool table using pool balls. The objective of the game is to keep the ball moving, or to get the ball in the goal, in order to get the falling person out. In addition to her playing skills, she wants to show how knowledgeable she is by demonstrating the physics behind the game. In this experiment, we will try to determine what will occur in 3 different situations. In the initial situation, one ball is stationary, while one ball with some velocity hits the stationary ball. In the second situation, 2 balls with the same velocity will collide with one another. In the final situation, one ball with a higher velocity will collide with the ball of lower velocity. Through this experiment, Thilly will demonstrate how physics is applicable to the real world. In the initial situation, one pool ball is stationary, while another ball with some velocity hits the stationary ball. This can be described as an elastic collision. As described in Newton's first law of motion, a body will stay at rest unless an outside force acts on it. In this situation, the stationary pool ball is at rest until the pool ball with some velocity hits it. Furthermore, Newton's third law of motion is also applicable. Newton's third law applies to pairs of bodies, in which body A exerts a force on body B. Then body B exerts an equal and opposite force on body A. When the balls collide, the energy is transferred from the moving pool ball to the stationary pool ball. The resulting velocity of the stationary ball will be the same as the moving pool ball. The moving pool ball, as a result, will come to rest. This results in an elastic collision because both the pool balls have equal masses in which kinetic energy and momentum are conserved. This is governed by the equation m1v1 equals m2v2, where both the left side and the right side of the equation are equal. This situation is similar to that of the pendulum, in which energy and momentum are always conserved.
In the second situation, 2 balls moving in opposite directions but with the same mass and velocity will collide with each other. This collision is considered an elastic collision, as the total kinetic energy of the 2 colliding objects is the same before and after the collision. To calculate any of the variables, the following equation can be used. It is half m1vi plus half m2vi equals half m1vf plus half m2vf. m1 represents the first pool ball used, and m2 represents the second pool ball used. Vi represents the initial velocity, and Vf represents the final velocity. Since both of the objects have the same mass and velocity, the momentum would be 0, as the final speed would be equal to the initial speed. Thus, the kinetic energy will not be higher either before or after the collision. Newton's third law can be applied to the situation, as the law states that the force exerted by mass A on B would be equal to and opposing to the force exerted by mass B on mass A. Thus, the force exerted by the first ball on the second ball during the elastic collision is equal and opposing to the force exerted by the second ball on the first ball.
In situation 3, 2 balls of the same mass will collide at different velocities, each coming from opposite directions. This represents a situation that is inelastic, meaning that the total kinetic energy is not conserved. This could go one of 2 ways, in which the balls collide and leave the situation with different velocities, making it an inelastic collision, or the balls leave with the same velocity after momentarily sticking together, making it a completely inelastic collision. However, without knowing the specific velocities of each pool ball, it cannot be determined whether the collision is completely inelastic or just inelastic. In both of these situations, momentum is conserved, which is why the conservation of momentum formula mi1 vi1 plus mi2 vi2 equals mf1 vf1 plus mf2 vf2 can be used. This conservation can be explained by Newton's third law, in which each action has an equal and opposite reaction. The initial kinetic energy is converted to other forms of energy after the collision, such as heat, ultimately resulting in less kinetic energy being present in the end, shown by 1/2 mvi squared not being equal to 1/2 mf squared. However, the initial and final sum of all the different types of energies remain the same from start to finish.
In all 3 of these situations, Thilly was able to understand the mechanics of CRABS, and thus was able to impress her man, Ash. With the help of Physics Girl, understanding the mechanics allowed both Thilly to impress her man and learn more about the connections between physics and the real world.